Welcome to Mākaha, Oahu. I've been here before. I've got some other videos from here. We're about to have a bit of a geologic event here. I'm sorry, it's not as exciting as a volcanic eruption, although there is a volcano a couple hundred miles that way that has been going off once a week. But what we're seeing right now is, we're here in this Mākaha Bay on the Mākaha beach on western Oahu. And if you look out there, you can kind of see the point there on the edge of the bay, and we kind of have a point here on the other edge of the bay. And in the middle here, we see a lot of beach sand. So what's the geologic event? Well, right now you can see that these waves are maybe, I don't know, 2 to 4 feet high or so. That's going to change starting about now, where they should start picking up, and in just a few hours, we're going to see waves that are 25 to 35 feet high. What's that going to do to the geology? Why is this a geologic event? Well, the points on the edges of the bay are very rocky. That's because they're getting eroded more. The waves come in, they're bending around those points and hitting it from all sides. They're pushing any sand out of the way, it's collecting more in the bay, and so you're getting erosion on the rocks, getting it broken down. So there's more erosion on the points of these bays than there is in the middle. So if you want to go swimming in the softest spot, the easiest spot in the bay, go right there in the middle where the sand is. You'll find the softest waves, because all the other waves are refracting in, they're bending in around the edges. So I'm going to develop a little bit of a hypothesis here. I know the major swells are going to come from the northwest, which is basically where that point is over there. We are facing to the west here. So actually the really big waves are going to be around that point on the other side of this little mountain. The waves out there are supposed to get 35 to 45 feet high, but they're going to bend around the island a little bit here. And so we should see 25 to 35. But I believe the main swell is going to come a little bit more from the northwest. My hypothesis is that's going to cause more erosion of this sand, and then the sand is going to get pushed down to this side of the bay. And right here we can see what looks like lava rock or basalt. It's not actually. I've got some other videos on this. This is actually limestone. If you get up close to it, you'll see it. This has actually been buried a little bit already over the last week or so. It used to be a bunch of rocky tide pools. But I'm guessing once we get those big waves in, they're going to come from down there. They're going to take all this sediment here behind me, all this sand, and they're going to push it to this side of the bay. And I'm guessing a lot of these rocks we see right here are going to be covered in a lot of sand. That is my hypothesis. There's the reasoning behind it. Now, I'm not certain. 25 to 35 foot waves are going to be about the biggest I've ever seen out here, probably the biggest I've ever seen out here. And maybe it'll just erode all the sand away. I'm not sure, but I think my hypothesis is sound. So we'll come back out here in a few hours, maybe at sunset or something, and kind of see how things have changed. But it is going to be a very kind of quick event. There's a lot of energy with these waves. I'm always amazed at how much and how quickly it can push the sediment around from one day to the next. You know, on the continent, on the lower 48, we see lots of sedimentation happening via the rivers, and out there when the rivers spit out onto the beaches, and this is different. We have calcite sand instead of quartz sand. It behaves a little bit differently, and then yeah, the sedimentation is just a bit different. And just for a little bit of a review, this sand, it's made out of calcite, but what's that calcite coming from? It's coming from seashells and corals. And when you get up closer to this stuff, you can actually see, I guess you can call it fossils, although this stuff hadn't been dead all that long. And so it's this stuff getting busted up in the waves, or the corals out there, gets rolled around on the beach as the waves go back and forth over and 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 over again. Gets rolled around and weathered into just tiny little bits of sand. And you can pick up some of the sand sometimes, or sometimes it collects in these little spots where you can see the bigger pieces, and you're like, oh yeah, that's totally seashells and little bits and pieces of coral. And if you kind of go play in the waves, you'll step on some pieces too. So you can kind of see it all in action and all of it happening. But yeah. This will be a little bit of a geologic event here, and it'll be kind of fun to look at and watch, and I'm very excited for the really big waves. I'm hoping it'll get nice and tall. We'll get a sunset over there, and maybe the sun will be shining through the waves. So I'll definitely come back out here at sunset, see what we can see, and see how it's changed. And yeah, should be fun. Geology is normally a slow process kind of thing, but out here on volcanic islands like you have in Hawaii, you know, those volcanoes are erupting, creating a lot more geology, a lot more rock, and then boy, the ocean is a powerful thing, and you can see changes fairly quickly. Instead of millions of years, it can happen in just a little bit of time, depending on where you look. So we'll see what happens, and I'll see you guys here in a little while. Okay, welcome back. It's been a little over 24 hours, maybe about 30 hours. So what happened is it took the swell a little bit of time to come in. It wasn't as quick as they were forecasting, but it came in. It's still happening here a little bit. And we're seeing, I don't know, maybe 15-foot waves. We're just at the end of a big set right here. So our hypothesis, or my hypothesis, was that this swell coming in from the northwest was going to push more sand down the beach. And here we are. I'm trying to stand roughly in the same spot I was before, and we can see that these chunks of limestone over here, well, there's less to see, right? So they've actually been buried a little bit. So some of the sand has been moved over here. Although I think a little bit farther over, you can kind of see there's a little bit of a platform right there as the wave kind of crashes up over it. It almost looks like to me that the sand was removed from there. So it's not quite as cut and dry as the sand being pushed in places. So I'm kind of, making observations and reevaluating that hypothesis. And my conclusion was that generally my hypothesis was correct, but there's more going on here than I think. I talked to my friend who kind of grew up here and knows this very well. And he was saying seasonally what tends to happen is that the sand will move up there at one part of the year, and then we'll kind of move down to this area another part of the year. And what he was mentioning to me was that the swell here will actually, the waves will tip over a little bit sooner when the sand migrates more to this southern end of the bay. And so we're seeing waves curl over out here a little bit quicker because the sand is actually moved within the bay itself. So we see sand up here on the beach, but also there's a lot of sediment, a lot of sand out here in the water. And you can see the waves will behave differently due to that. A little bit of history here about Mākaha. This used to be one of the surfing meccas in Hawaii. It's not so much anymore now. You do see a lot of surfers out here. There was a bunch out here today. There's still a few over there. And that's because the waves used to curl over a lot better. And there's geology reasons for that that don't exist anymore due to a major hurricane that came through here. I think it was Aniki. It might have been the other one. And it changed. There was so much erosion and so much change. And he said so much sand was removed from this bay due to that hurricane that it changed what's going on in the bottom of it, and you don't have the same waves anymore. So the geology literally changing the culture of this area. And so it's kind of a neat sort of historical thing that's occurred here. But yeah, the waves have come in. We've seen this sediment move. And to me, it's pretty amazing because you don't typically see changes this fast, right? Yeah, it's been 30 hours, but honestly, I could have come out here at night and we would have seen a lot of this sand had already been moved. Just due to slight weather changes, I think there was a little bit of a low pressure system that kind of came through and pushed all this swell in through here. And yeah, moved the sand around. But pretty neat to kind of pay attention and notice it. And if you learn geology, you'll pick up on these things in a lot of different places, and you'll see things that other people don't see. And that to me, that's why I love geology so much. Is somebody may see a pretty mountain or the waves are nice, but if you understand what the processes that make these things, there's more of a story there. When you look at something that looks pretty, now you see the story behind it, and there's more there. So yeah. Hopefully you thought this was kind of nifty, and I'll see you in class. All right, so just for fun, it's been about 48 hours since the big swell started coming in, and that limestone is now buried. There's nothing there. The sand now goes a good bit farther out into the waves. That partially might be because maybe we're at low tide. I'm not sure what the tides are doing now. But yeah, that thing is sticking less up out of the sand. And there's no big limestone rocks right here. So overnight, I think the tide probably came up. The waves continued to be about 20 feet. And it moved all the sand in and buried that limestone. So yeah, kind of neat. Fast sedimentation. Just in a couple of days, moving tons and tons and tons and tons and tons of sand. Yeah, geology in action.